Welcome to another fun-filled, fabulous edition of Comet Algebra. This video is for Algebra 1, Chapter 5, Section 7, Graphing Absolute Value Functions. So just let me remind you of the definition of absolute value back when we were working on a number line. No matter which way we were going from the number line in the positive or negative direction, the absolute value is defined to be the distance from zero. And that is why absolute value is always positive, because it represents a distance, and you cannot travel a negative distance. So from this definition we conclude that the absolute value of x is x if that number is positive, and the absolute value of x is x if x is negative. In other words, x is always positive. Okay, I think we established that. So let's do a little more with absolute value. Now, example 1 asks us to represent the absolute value function, f of x equals absolute value, given this particular domain. They want us to represent it as first a table, then a set of ordered pairs, and then a graph. So if we first set up the table, you know that the domain values go in the x, so let's just put those in here. And let's figure out the y values that go with these inputs. So the -3 going into the absolute value becomes positive, likewise with the 2 and the 1, and if the number is positive, it stays positive. So now let's write this as a set of ordered pairs. You know that we use set notation to write these pairs, so we'll put -3, 3, -2, 2, and so on, putting each input with its output and using those brackets. I can't do very well for a set notation. Okay, the third thing we're asked to do is graph this. And this graph may look familiar to you because we did something like it about, I think it was in section 5 when we were learning about function rules. So like I said, hope this looks familiar. So at -3, we're up here at +3, -2, we're at +2 rather, -1, +1, 0, 0, 1, 1, 2, 2, 3, 3, and so on. Oh, I shouldn't say and so on. In this particular case, we are limited to this domain. So these dots, I can't draw actual circles with this, little small dots with this pen. So for these, I'll try my best here. These dots are it. This domain is limited to these values, so that's it. That's the graph. We do not connect the dots. Now in example 2, we're asked to graph the function absolute value of x plus 4. So once again, we make a t-chart, and we need to put in both some negative and positive values, so we make sure we get both sides of the v. So if we take this -3, put it in for x, we get +3, plus 4 is 7. Putting in the 2, we get 6. Putting in the -1, we get 5. Putting in the 0, we get 4. 1 is 5. 2 is 6. 3 is 7. So now let's graph these. So here at -3, we're up here at 7. At -2, we're at 6. At -1, we're at 5. So this v is looking a little different than the first graph. And at 0, we're right here at 4. 1, back up to 5. +2, 6. +3, 7. And notice this time I do not have any limits on the domain. The domain is all reals. So in this graph, we do connect the dots. And this v is no longer sitting, well, if I could connect the dots, that'd be great, is no longer sitting on the origin. This +4 had an effect on this v. It took the v and moved it from down here somewhere, it moved it up 4. So take note of that. I'd like you to predict, what do you suppose would be the graph of absolute value of x minus 2. So think about that for just a minute. So I went ahead and made the t-chart, put in the same, I just picked some numbers, the -3 to +3, but the output is looking a little strange here. So let's graph this and see what it is we have. At -3, we're here at +1. At -2, we're at 0. At -1, we're down here at -1, but this looks weird because it's absolute value. Should we be down here in negative? And at 0, we're all the way down here at -2. Now at +1, we're at -1. At +2, we're back up to 0. And at 3, we're up at 1. So now I can kind of see what the graph did. The V got moved down. In fact, it got moved down 2 units. So that's what this -2 did to the V. It moved it down. These two things that we just did, we took the V and we moved it up 4 in the last example. In this example, we moved it down 2. What we're doing is called translations. A translation is when you take the original graph and you move it all around. Now we've moved it up and down. The translations can also go left to right. So let's see if we can figure that out. But before we translate this graph left and right, let's define one more term, very familiar to you, I hope, is the term vertex. The mathematical definition for it is that it's the turning point of the graph. Now, a turning point means that here the graph was going down in a negative direction, a negative slope, and here it turned around and now it's going up in a positive slope. So that's the mathematical definition. Another definition could be a maximum value on the graph. Now, this particular graph that we're looking up right here does not have a maximum. It keeps on going up forever in both directions. But a vertex can also be a minimum point. And that's what we have here in this case. So this point right here is the vertex. It's the lowest point of the graph. Another definition is the turning point. Next example, we're asked to graph x plus 3, all of it inside the absolute value symbols. So let me set up the t-chart just like we always have, and we'll see what we have here. Now you'll notice in this t-chart, I started way down here with -6, and there's a reason for that, and I think you'll see. Putting in the -6 here, -6 plus 3 is -3, and the absolute value of that is +3. Putting in the -5, we get a -2, which is +2. Putting in the 4, we get -1, which is +1. This gives us 0. This gives us 1. This gives us 2. And this gives us 3. So let's graph these points to see what it looks like. So here at -6, I'm up at +3. At -5 at 2. -4 at 1, and right here at -3, I'm back to the 0. At -2, I'm up here at 1, -1, it's climbing again, and at 0, I'm up to 3. So this translation took the V that had originally been here at 0, 0, and moved it over to the left 3 units. Now, doesn't that seem odd that here inside the absolute value we have x plus 3, but the translation moved the graph in the negative direction? So that's kind of interesting. So please take note of that, and let's see what happens if we put a minus, an x minus something inside the absolute value. So I set up the t-chart again, and you'll notice I started with the 2 and went up. Now, if you are graphing an absolute value and you only get a straight line, that means you haven't gone far enough to find the vertex. So make sure you extend your t-chart long enough to find the turnaround point of the graph. So putting in the 2 take away 5 is -3, which becomes +3. Putting in the 3, negative 2 is positive 2, negative 1 is positive 1. Putting in the 5, we get 0. Putting in the 6 is 1, 7 is 2, 8 is 3. So now let's graph these and see what it looks like. So here at 2, I'm up at 3. At 3, we're down to 2. Here at 4, I'm up at 1. And at 5, I've reached the x-axis at 0. 6, back, we're up at 1. 7 to 2. And 8 to 3. And so now we notice this is a different translation. This took the absolute value v from where it was here at the origin, and it moved it to the right 5 units. And again, doesn't that seem odd that the equation had a negative 5 in it, but it moved the vertex and the whole graph 5 units in the positive direction? So there's a little backwards thing going on here that you need to take note of. So just to sum up a little bit before we do example 6, when we had a positive 2 outside the absolute value, that moved the graph up those many units. When we had a negative, a subtract outside the absolute value, that moved the graph down that many units. When we had a subtract sign inside the absolute value, instead of moving it in the negative direction to the left, it moved the graph to the right that many units. And then when we had a plus inside the absolute value, instead of moving it in the positive direction, it moved it to the left that many units. So you need to write that down somehow. I didn't spell it out for you, but I want you to have that in your notes in a way that's helpful to you. So now let's go ahead and do example 6. We are asked to state the coordinates, meaning the location of the vertex on the graph. So we learned that the translation here, plus 4, that it would go up 4 units. Therefore, the vertex would be at 0, 4. Here, this subtract 1 inside the absolute value, this moved it to the left 1 unit. And so then the vertex of this graph would be to the right 1 and then 0, so it's 1, 0. Now this is the first time we've had 2 translations. So this positive 3, it moved the graph in the negative direction 3, and then this plus 5 moved it up 5. So 2 things happened. It went in the negative direction 3, and then it went up 5, so the vertex is at negative 3, 5. Same thing with D here. This had 2 things, 2 different translations. So this negative 6 moved the graph in the positive direction 6 units, and then this subtract 7 moved it down 7 units. And so this vertex ended up at 6, negative 7. So now we have sort of some backwards problems. We're given the translation described to us, and we have to write the function rule or the equation. So in this case, we went down 9 units, so down 9, and then it went to the left this way 8 units, which is in the negative direction. So we learned that inside the absolute value, if it went in the negative direction, that isn't x minus 8, it's that backwards thing, it's x plus 8. But then when it just went down 9 units, that's just a normal subtract 9. Next translation, it went to the right 0.25 units, and then it went up 2.1 units. Well, if it went to the right, that's in the positive direction, but we don't have the plus inside the absolute value. Remember, it's the backwards thing. So we'd have x minus the 0.25 in the absolute value, and then we would add the 2.1 to move it up 1. Okay, why don't you try these ahead of me, hit pause, and then we'll do them together. Okay, I hope you gave them a try. 5 units to the left. that means it's moving in the negative direction 5 units. So we know if we're going in the negative direction, it's not minus 5 in here, it's plus 5. And then we're going up 2, so that's easy, that's plus 2. Last one I'm going to help you with here, last example. We are going to the right 2 units. That's in the positive direction. So we've got the backwards thing, so it's a minus 2. And then if we go 1 unit down, that's a minus 1. All right, I think you have the knowledge you need to do section 5.7. So have fun with math.